It's our video for lesson 4.1. So lesson 4.1 is really doing the same things that we've already been doing. We're just going in a different order. So we've already taken equations and then from that graphed those equations, found slope, and found the y-intercept, and now we're just reversing it. So I'm going to give you a function, or I'm going to give you a graph, or I'm going to give you some points or a table, and you need to write the equation. We do need to remember function notation, and that's just with, instead of y, we'll be writing f of x, right? And that's what this means, f of x equals something. That's our function. But we can think of this as just being y, right? And then whatever's in the parentheses, that's our x value. So you might see something written like this, and that's just communicating a point to you. So we would say f of -2 is 1. That's how we would say that. And this represents an x and a y coordinate, where that x value is -2 and the y value is 1. So really, you just need to learn how to kind of interpret this, or recognize that this is just another way of, we can share what would be a solution to this function, right? So it's doing more than just giving you a point. It's really saying that we have this function or this equation, and when x is 3, y is 4. But for the purpose of what we're doing, you can just think of it as a point that you will use in order to help you write the equation. Slope we're going to be using again, so it's imperative that you learn and memorize at least this, y2 minus y1 over x2 minus x1, or if you're using a graph, you can just count and figure out change in y over change in x. The form we're using is this y equals mx plus b, where m is that slope and b is the y-intercept. So in all of these problems looking forward, we just need to find these two things. Once I find the value of our slope, I'm just going to plug that into our equation right there. Once I find the y-intercept, I'm just going to plug it into our equation right there, and we're done. So for example, in example 1, there's absolutely nothing to do but plug these values into our equation. Our starting form is y equals mx plus b, and it tells us slope is -3. So instead of m, I'm going to write -3. Y-intercept is 1/2. So instead of b, I'm going to just write 1/2. That's it. Number 2, same thing. We end up with a slightly interesting case here because our slope is 0 and our y-intercept is negative, not b, it's -2, right? So I know our form says y equals mx plus b, but all that means is if b is positive, then we'll get a plus. If b is negative, we're going to have a minus. And we should also recognize if this is 0x, 0 times anything is just 0, so the most correct way to write this is just y equals -2, where that's going to be a horizontal line at 2, right? So if just kind of sketching this out, the equation of this second one, that would be this line right here, y equals, -2, not +2. So it would be down here instead. Y equals -2. There we go. All right, so when that x, when the slope is 0, we have a horizontal line. Okay, moving on, looking at a graph. So we're going to need to do a little bit more work here, but again, we're still looking for the same things. What is my slope and what is my y-intercept? Y-intercept we can just pluck right off the graph, right? That's where it crosses the y-axis. So the y-intercept is -3. And then the slope, if you've got a graph, again, you can count. Just be careful with the scale on this particular graph. So if we're thinking rise over run, we've got 1, 2, 3, 4, 5, 6 is our rise, and then our run would be 1, 2, 3, 4 because of the scale of this graph. So I'm going to actually do this in a couple different ways. So if we think of it as change in y over change in x, what did I say? Up 6. 1, 2, 3, 4, 5, 6 over 4. And we should always simplify this to 3 over 2. Or we can use the coordinates. Remember y2, getting a little crunched here on my page, y2 minus y1 over x2 minus x1. So I've just got my two coordinates here, right? This is an x and a y, so I'd call that x1, y1. And this is my second point, so x2, y2. So if I plug those values in here, I've got 3 minus negative 3 over 4 minus 0, or 6 over 4, which again, we should reduce to 3 over 2. Once we know the slope and the y-intercept, I am a little out of room here. I'm going to use the bottom of the page. Slope is 3 over 2, so y equals 3 over 2 times x. Y-intercept is negative 3. There we go. Same thing over here. Slope. We know we've got a negative slope now because it's going down and away. So I'm going to count, change in y, 1, 2, 3. Change in x, 1, 2, 3, 4. So negative 3 over 4. My y-intercept is at 2. So my equation, negative 3/4 x plus 2. Notice I'm going through this really quickly. If you're watching a video, you may certainly need to pause and kind of think through some of this stuff. I don't expect you to grasp it quite as quickly as I'm saying it, but that's the nice thing about video. Okay, write an equation again. So now we just have coordinates. What you need to notice here is when my x value is 0, so I'm looking at this point right here, when x is 0, y is negative 1. That's going to be my y-intercept, okay? Whatever that point is where x is 0, think about plotting this point. X is 0, y is negative 1. That point is right here. That's my y-intercept. Okay, so right now, you're always going to be given a nice point like this where one of them is going to just tell you your y-intercept. For slope, we still need to calculate that. Negative 1 minus 5 over 0 minus negative 3 gives us negative 1 minus 5 is negative 6 over 3, which I don't want to run into this here. My slope would be negative 2 over 1, which if you want to just write it as negative 2, that's technically correct. So our equation, y equals negative 2x minus 1. Same thing over here. If you notice y2 minus y1, that's the same number. So that's just going to give us 0 over 8, which is a slope of 0. My y-intercept is negative 5.8. So, which we saw this example earlier, it's most appropriate to just write it like this. Slope of 0, that's just a horizontal line. And then finally, function notation. Again, we discussed this earlier. This first f of 0 equals 10. That tells me that one of my coordinates has an x value of 0 and a y of 10. The other has a x of 6 and a y of 34. Okay, so find my slope. 34 minus 10, y2 minus y1 over x2 minus x1 gives us 24 over 6, which is the same as 4 over 1. We already have our y-intercept, right? When x is 0, the y value is going to be the y-intercept. Y equals 4 over 1x